Okay, let's have a look at this example on page 46, please, for acid-base titrations. Washing soda is mainly sodium carbonate. Washing soda is added to hard water that contains a lot of mineral ions, for example calcium ions, and hard water is hard to get a lather. Remember when I first came to Tasmania many years ago, going to Queenstown and having a bath. The water was yellow and I could not get a lather. It was quite an interesting experience. I felt dirtier after the bath than before. Anyway, in this case we're reacting 0.300 gram sample of washing soda with 20 mils, and washing soda is sodium carbonate, and so it's a solid. We're reacting it with hydrochloric acid. What do we know about the hydrochloric acid? We know the volume. It's 20 mils. And there's a few of you who are struggling with your mils to litres conversions for volumes. And we know we have a concentration of 0.250 moles per litre. So because we have those two pieces of information about our acid, we know that we can find the moles, don't we? Because N equals concentration times the volume. I can find the moles of acid by multiplying these two values together. I write all the significant figures as given in a question. I notice some of you aren't, and I think that's also making it more difficult for you to come up with the correct answer. So it's a good habit to get into. 0.00500 moles of acid. Now we need to look at the balanced chemical equation. And we know we can be expected to write the equation as is in the case for that test. If I react an acid and a carbonate, I know I produce water, carbon dioxide gas, and a salt, which is going to be sodium chloride. So now I need to balance it. I've got 2 sodiums in the sodium carbonate. I'm going to need 2 sodiums in my sodium chloride. I also need 2 chloride ions and 2 hydrogens on this side, so I need 2 there. And again, this is another place where some of you were having some problems is, well, I've got the balanced equation. I know how many moles I have of this. This is what I have. Okay, some of you then would look at this too and then multiply that value by 2, but you don't have that much. This is how much you have. So I have 0.00500 moles of, and we were told that it reacted completely with the acid. So if this is a 1:2 ratio, then I need half. It's going to be half of this, isn't it? So this is a half times. So the N of Na2CO3 is a half of the moles of HCl. And 0.00250 moles. Okay, so we found the moles. And now we will need to find the mass. And our sample mass is equal to our moles multiplied by the molar mass of the substance. So my mass of sodium carbonate will equal the moles multiplied by, what have we got, 2 times, is it 22.9 for sodium? 99. 12.01 plus 3 times 16. And we're just going to use the value in the booklet here. It tells me that the mass is 0.265 grams. So this was my impure mass. This was the washing soda. That obviously had other stuff in there. And so for my percent sodium carbonate in washing soda, it's going to be this, which is the pure value, divided by the impure mass, and then multiplied by 100 to make it into a percent. And we get 88.3%. Now, some of you with your creative maths in that last assignment were getting really big values for your mass down here, and so rather than go through and end up with 400 or 500%, swapped it over so that the smaller number was on top. Unfortunately, that means that you've made another error. If this number's wrong and you know it's wrong, what you do is you just do the calculation correctly. You get the 500% or whatever it is, and you just write there and say, I know I've made a mistake earlier, but I can't see where. Then you're only penalised for the one time you made the mistake rather than twice for trying to fudge an answer. Does that make sense? Yeah. So your process needs to be mathematically correct, because we all make mistakes. Okay?